In this video, I want to do a quick example of how to use Euler's formula to derive the angle addition formulas for cosine and sine. So these are not expressions that I particularly have memorized. It's nice to be able to rederive them. It's not too bad of a computation. So at the end of our computation, we will find that cosine of alpha plus beta, where imagine those are two angles, is the product of the cosines of those angles minus the product of the sines. Whereas sine of alpha plus beta is the sum of the mixed terms. Maybe I should just say it. It's sine of alpha cosine of beta plus sine of beta cosine of alpha, vice versa. It's the same thing. Okay, so how do we get this? We get it with Euler's formula. I think I can do this all in one computation. So I'm going to say, what is cosine alpha plus beta plus I sine of alpha plus beta? Kind of going backwards compared to how we usually use Euler's formula. We usually start with the complex exponential and break that into cosine and sine with the real and imaginary part. I'm going backwards here, I'm going to say that this is e to the I alpha plus beta. Distribute. That is e to the I alpha plus e to the I beta. Oh, sorry, I wrote that wrong. E to the I alpha plus I beta. There we go. I can break this apart into two exponential functions though, but it's not going to be their sum, it's their product. So this is e to the I alpha, e to the I beta. Now this is the product of two complex exponentials. Let's use Euler's formula on each one. So for e to the I alpha, we'll say that that is cosine of alpha plus I sine of alpha. And then likewise for the second one, this exponential function e to the I beta is cosine of beta plus I sine of beta. Okay. Take a moment if you'd like to pause, work it out. You should get to the conclusion on your own, but I will come back and show you how to finish this computation. All right, if you expanded this product, what you should have found is that we'll have cosine alpha, cosine beta. Then next, I'm actually going to move on to the product of these two terms. That would be I squared sine alpha sine beta. But I squared is -1, so that's minus sine alpha sine beta. And then let's add to that this product and this product. Both have the imaginary number I. So I'm going to pull that in front. And we'll have, I'm going to start with this one, sine alpha cosine beta. Plus sine beta cosine alpha. Like that. And now it's an exercise in matching real and imaginary components. So the real component that we started with was the cosine of the angle sum. So cosine of alpha plus beta. That has to be equal to the real component of this expression, which is the product of the cosines minus the product of the sines. On the other hand, the imaginary component is this sine of alpha plus beta. That is equal to this imaginary component. So we have the sum of the mixed expressions. Okay, so I think it's fun to work through these kinds of computations. From this, you can get the double angle formula. You could get it from this, or you could actually try to work that out again as an exercise and using Euler's formula on your own. Okay, thank you for your attention.